This work is for the homework 10 question 2, and in the question 2, first the wide sense stationary, which means is a constant, and autocorrelation is a function of time difference. There are a lot of examples of wide sense stationary, such. In practice, they are much similar to get the second-order density based on the mean and the autocorrelation function. So we can do state estimation, parameter estimation, and prediction in mean square signs. In communication application, power of the signal is important. So when we put the input is a wide sense stationary process, the output of LTI system is also wide sense stationary. And second, the independent increment process means when xt1 minus xt2 and xt3 minus xt4 are non-overlapping, then the intervals are independent. So far, we have seen that the Poisson process is an independent increment process, and which is somehow related to the Markov process. And the Markov process, if the past has no influence on the future, when the present now is no. So the Poisson process, as we said, is a Markov process. It's not related with the time, and there are a lot of examples, such as for the such as when we play the computer, we buy some box, we buy something, and the probability we open the box, open some treasure is the Markov probability. Markov process is not related on the time. If the past have no influence on the future, so when the present is no, and the first question, a process xt is said to be a normal if the random variables xt1 to xtn are jointly normal for any n, and any the time t1, t2, such etc. as the tn, that is the function of xt1 with the xt1 to tn has a relationship, has an equation, and which is the normal, and this is the normal distribution. And also the strict sense stationary process is if the statistic is not affected by a shift on the time axis. The white noise is a statistical process. Vt is said to be when its expansion equal to 0, and its autocorrelation is the qt1 multiplied the delta t1 minus t2, and the mean ergodic if the limitation of the t near to the infinity, and the integrated of the xt is equal to the expansion of xt, and which means it's in mean square sense, and the mean of the xt is equal to a constant. And so we can get it when we put the mean square signs, the mean ergodic will appear just like the integrated of xt minus the n, and the expansion is equals to 0. So this is the homework 10's question 2.